Alright, today we're going to be talking about one-step inequalities and really other inequalities as well. And today we're going to be starting with something that doesn't just say a variable is less than or equal to or greater than or equal to or less than or greater than. We're going to have some things, and just like we solved equations, we're going to solve these inequalities using the same ideas. All right. So let's go ahead and look at these. The first couple here are one-step inequalities. In fact, the whole first page is. Once we get going, we'll learn how to do two-step inequalities just like we did two-step equations. And we're also going to look on how to check our answer. That's a really important part there. All right. So if I was solving an equation and I pretended this was an equal sign instead of less than or equal to, I'm going to go ahead and subtract 3 from both sides. All right, those cancel. 8 minus 3 is 5. So we say that 5 is less than or equal to x. All right. Some people prefer to write that the other way, write the variable first. In fact, I do as well. It makes life a little bit easier. And so x is, and since I'm writing x first, I need to make sure that the big N still opens towards x. And so that says that x is greater than or equal to 5. All right, remember, I have number lines here for you, and the main numbers I'm worried about is where is 0 and where is the number we're worried about, 5. Okay, I don't care about the scale. Yeah, that's only 4 spaces. I could have gone 5, but maybe each space is whatever it needs to be, 1.2 or whatever. It's not a big deal that you worry about that. I just want to know that you can graph them and you can put the proper dot and shade the proper way. So let's look here. X can be 5 or anything bigger than 5. So since it can be 5, we'll fill in that circle. And numbers that are bigger than 5 live to the right. Remember, vertical shading the entire way to the arrow and make the arrow bigger and fill it in also. Those are the things that I'm looking for when I'm checking your graphing abilities. So let's look at what would be a number bigger than 5. Let's just make sure this works. Let's say we have 7. Okay, 7's bigger than 5, and I'm going to plug 7 in. So I'm going to use my original equation, or inequality, sorry. And it says that 8 is less than or equal to, instead of x, I'm going to put 7 in there. 7 plus 3. So is 8 less than or equal to 7 plus 3, which is 10? Is 8 less than 10 or equal to 10? Yes, it is. So we're good. That's how you check your work. Not a lot of stuff to do, but very important nonetheless. Okay. Let's go with the next one. All right, I have x minus 7 is greater than 15. So I want to add 7 to both sides. And it says that x is greater than 15 plus 7 is 22. Okay. Now, let's start off by graphing this. And let's just say that I have 0 over here somewhere and maybe 22 right there. Again, not worried about the scale, just worried about graphing it correctly. All right, so can it be 22? It cannot. There's no line underneath that inequality, so it can't be 22. So we'll open circle that. And I want to shade the numbers that are bigger. Bigger numbers live to the right. And so we shade over there. All the way to the arrow, block the arrow, and we're good to go. Let's check it really quick. What's a number that's bigger than 22? I'm going to use 27. All right, 27 is bigger than 22. And let's plug that in for x. 27 minus 7. Is that greater than 15? Really, you should have the question mark above that because we don't know that it works out. Sometimes I'll write that, sometimes I just won't. I forget about it. But 27 minus 7, that's just 20. That's why I picked 27. Made it easy. All right. And now is 20 bigger than 15? Yes, it is. All right. Never do I want to pick the number in question, that the 22 in this case, or even the 5 in this case. I don't want to pick that because I know by the symbol whether it's going to be true or false. So 5 would have worked here, and it wouldn't have worked here, and it doesn't tell me anything about the shading direction. So since here 27, we plug that in, since that's true, that number's right here, and I know that I shaded the correct way. Does that make sense? Okay. Let's move on to the next two. What I want to do is, on this one, since I have x divided by 3, I want to multiply by 3 on both sides. I'm going to kind of go into the note space here. Multiply by 3, multiply by 3, and I'll get that x is greater than or equal to. So greater than or equal to negative 12 times 3 is negative 36. Okay? So negative 36, let's say it's right here. That would make 0 over this way somewhere. Okay, and let's just put it there just for kicks. So I want to shade in all the numbers that are bigger than 36 and 36 itself because of the line under the inequality. So I have 36 is a good one. It works. And all numbers bigger numbers live to the right. Okay, bigger numbers live to the right. Shaded that in. Let's go ahead and check it. Whenever I can, I like to check 0 because it makes things kind of easy. So instead of x, I'm going to put in a 0. So is 0 divided by 3 greater than or equal to negative 12? Well, 0 divided by 3 is just 0. So is 0 greater than or equal to negative 12? 12. Yes, it is. All right, so we know that works. 0 would have a dot on it. It would be one of the many points with dots. So we're good to go. Let's look at this last one here, and we'll get on to something a little bit trickier. We'll divide by 7 on both sides. When I go 196 divided by 7, feel free to use a calculator. It'll help you out quite a bit. So those 7's cancel, and I get x is less than 28. Okay, 28 is what we come up with there. So let's say 28. So let's say I have 0 here, and maybe 28's over here. Okay. Can it be 28? No, it can't. So that's an open circle. And I want numbers that are smaller than 28. So we shade this way. Shade that in. And let's see what numbers are, in my mind, smaller than 28. Well, 0 is. Let's make sure that works. Okay. So let's plug in 0. Plug in 0 again to the original inequality. 7 times 0. Is that less than 196? Well, 7 times 0 is 0. That's why I picked it. Made it easy. 196 is definitely bigger than 0, so that works. Okay? And that means that we shaded the correct way. All right. So I have, in parentheses here, what's different, expect to be amazed. I don't know if you'll be amazed as much as annoyed. Okay, I usually get annoyed by these problems. I'm going to do this problem in my 2 different colors here. I think it's a black and a purple. And we're going to see what happens. All right. I'm just going to do the problem like I feel like I should. I should divide by negative 4 on both sides. Okay. And so what we're going to do here is negative 4's cancel. So x less than 36 divided by negative 4 would be a negative 9. All right. Now, let's say that we have, maybe 0 over here and a negative 9 there. And I want numbers that it can't be negative 9, but it could be anything smaller than negative 9. So this is what my gut tells me I need to do. Okay. And now let's check it. Let's say, well, Negative 10 should be over here. All right, that's smaller than negative 9. Now let's check that in our equation. So negative 4 times negative 10, is that less than 36? Okay. Negative 4 times negative 10 would be 40. Now is that less than 36? No, it's not. Okay. So it's not. That means that we screwed up somewhere, and it's nothing that you should know. I mean, if you know the trick here, then that's great for you. I'm proud of you. Hopefully you remembered it. But the key here is that whenever you divide by a negative, it kind of throws things off. All right. And so let's check another number. You know, your gut tells you that if negative 10 didn't work, well, what happens if I use 0? Okay, because 0 is on the other side. And let's say we have 0. So I'm going to go negative 4 times 0 less than 36. Well, anything times 0 is 0, and 0 is less than 36. All right, that does work. So what I should do is I should shade this way. Now, I haven't told you guys this. Yet, but there is a reason that we shade the way we do. And whenever you're writing a problem out, and I've had this happen quite a bit before, is that people, you know, they'll put the numbers that they need. So I need negative 9, and I need 0. Okay, and they do it right. They say, well, it should be numbers bigger than negative 9 here. So our answer should be that x is greater than negative 9. Okay, and the way they graph that is they put the open circle at negative 9, and then some people just draw over the number line. Okay, I can't really tell that, you know, maybe you just double, you know, and you just went over the number line again or what, but that doesn't, and people write that as their answer, you know, and I can't really tell which way you shaded. That's why we're going to shade this way. Okay, and it doesn't have to be pretty, but some people need that cleanliness, and so, you know, sometimes I'll even go over it again, make it look a little bit better. But the trick here is for these problems that whenever you, and I'm going to put this under the rule, whenever you multiply or divide multiply or divide by a negative, you must flip the inequality. All right, and that's what I did to actually make my answer correct. You know, if I plugged in 0, 0 was on this side, so 0 was greater than negative 9, even though the problem said, okay, all numbers smaller than negative 9 or negative 4x is less than 36. We have to flip that when we divide by that negative. All right, so right here, in this step right here, we should have flipped our inequality. Okay, now let's go ahead and try that on this next one. So I have negative x over 11 or x over negative 11, however you want to see that. The way I get rid of this is I'm going to multiply by a negative 11. Okay, remember the key here is whenever I multiply or divide, not when I add or subtract, because I added or subtracted a negative. Let's see, up here in the first one I subtracted a negative, and that was fine, nothing screwed up there. It's when I multiplied or divided by a negative that I came into an issue. So whenever we multiply by a negative or divide by a negative, we're going to flip that inequality. So these 11s cancel over here, and so do the negatives. All right, but I get x instead of greater than or equal to, I just flip that inequality and go less than or equal to. All right, so notice they are different. And 7 times negative 11 is negative 77. All right, not too bad of a deal. and we'll check that it works here in just a second. So, excuse me. Let's go ahead and, yeah, we're going to solve that here. Or, not, we already solved it, but we're going to graph it. So let's say 0 is over here and negative 77 somewhere in this region. Okay? It can be negative 77, and my claim is that it can be anything less than negative 77. Smaller numbers live to the left. And there we go. Okay? And we'll just check that. I'm going to pick what I call a smart number that helps helps the problem work out a little bit. So I look at the original, and I'm going to plug in a number smaller than negative 77. I'm going to use negative 99 because that works. That's smaller than negative 77. So I'm going to go negative 99 over, I'm going to put that negative down below. I usually don't do that, but I will here. Over negative 11, because the negative 99 was just the number I picked. There's still the negative that comes with the problem. And now, is that greater than or equal to 7? All right. Negative 99 divided by negative 11 will be a positive 9. And positive 9 is greater than or equal to positive 7. So we're good to go. All right. So that's just a key rule to remember. Make sure you write that down. And once you get that done, I want you to pause the video and try these last 3 problems. All right, hopefully you got a chance to get those done. Let's go ahead and work through them real quick. I don't want to take too much time on these. Multiply by 4, and I get negative 36. Even though this is a negative and I'm multiplying, it doesn't mean I flip because I multiplied by a positive. All right, so no flipping here, and we get negative 36 is less than or equal to b. If you want to rewrite that, you can. You don't have to, though. Let's just put negative 36 here. I like that I put it right in between those 2 lines. I'm going to make it that one right there. All right, that would put 0 up here somewhere. And so it can be negative 36, so that'll be a closed-in dot. And if I just read this backwards, it says that b is greater than negative 36. Even though we read left to right, we can look at it the other way, or you can just rewrite it either way. Because, some people start saying, well, all you're doing is you're shading the way the arrow points. If you think of this as an arrow, it's pointing to the left. Well, you should shade to the left. Well, that's not where bigger numbers live. Okay, b is bigger than negative 36. So that's why I don't agree with, we'll just shade the way the arrow points. People say that sometimes, and it makes me upset. If you understand the concept of it all, you're going to understand it for longer and not just the quick way to do it. So I know that 0 should be in that region. So let's plug in 0. Is negative 9 less than or equal to 0 over 4? 0 over 4 is 0. So is negative 9 less than 0 or equal to 0? Yes, it is. So we're good to go. That is checked. All right. Next one, we are adding or subtracting 7 here to solve. Remember, I do the opposite. Those cancel out. X greater than. That'll be a 2. So let's put 0 there and put a 2 there. So I need numbers bigger than 2, but it cannot be 2. So we get an open circle, shade to the right. And my arrow's not looking very good today, but it works. Okay. What's a bigger number than 2? Well, maybe 5's up there. Let's try 5. Okay, we're going to plug 5 in for x. So 5 plus 7, is that bigger than 9? 5 plus 7, that's 12. And 12 is bigger than 9, so we're good to go. All right, last one, and we'll go to the next page. To solve this, I want to divide by negative 11. Uh-oh, dividing by negative. What do? Don't freak out, all right? All you got to do is flip that inequality. And when you figure that out, negative 110 divided by 11 is a positive 10. flip the inequality, and K. I'm going to rewrite this one. Some people, like I said, do like to rewrite it. I'm going to rewrite it with K in front. And you kind of look at it, well, you flipped the inequality again. Why'd you do that? No, I just wrote the entire thing backwards. Okay, when you write the entire thing backwards, you do end up kind of flipping that inequality, but it all works out in the end. So 0's there. We need 10. It can be 10, and it can be any number smaller than 10. So I shade to the left. To check it, again, when I can, I use 0. Why not? Use 0 in the original. So negative 110 less than or equal to negative 11 times 0. Negative 110 is less than or equal to 0. So that works out. We're good to go. We shaded the proper direction. Let's move on to the next page. I'm going to bring this back up top. Here we go. Now we're getting into multi-step inequalities. All right, even though today's target's about one step, or actually today's not about one step. Sorry, today's about one variable inequalities. There's only one variable in these problems, not two of them. Okay. So to solve this, I'm going to go ahead and add 1 first, just like you'd solve an equation. Okay, don't get freaked out because there's multiple steps here. But negative 80 plus 1, or sorry, negative 81 plus 1 is going to be negative 80. And that's greater than or equal to 4v. Divide by 4. Divide by 4. We have negative 20 is less than or greater than or equal to v. All right. So let's put negative 20 here and 0 right there. Now I need all numbers. This actually says, if I were to rewrite it, and I rewrite it the other way, that v is less than or equal to negative 20. So it can be 20, and all numbers that are smaller than 20 that go this way. That's where the smaller numbers are. Okay. So what I'm going to do now is I'm going to plug in a number and check my solution here. I'll just pick any number. Let's see. I'm going to go with, oh geez, what do we want to do? Let's go negative 25. Okay, that lives over there. So let's check it. Might run out of room here, but we have negative 81. Is that greater than or equal to negative 1 times, negative 1 plus 4 times negative 25? So let's see here. Negative 81. It's a little more work here, but nothing to be too worried about. 4 times negative 25, that's going to be negative 100. Negative 100 plus negative 1 is going to be negative 101. So is 81 bigger than negative 101? It is, because it's less negative, I guess, is the easiest way to say it. If you had negative 81 and negative 101 plotted on a number line, negative 81 would be farther to the right. So that means that it works out. Okay? All right, let's move on to the next one. Here we're going to add 6. Add 6. Those cancel. K over negative 5 is greater than or equal to negative 6 plus 6 is 0. Okay. My next step is to multiply by a negative. Uh-oh, we're multiplying negatives. We need to flip that inequality. It's actually a pretty easy multiplication, though, because we're multiplying by 0. So we're going to flip that inequality, and 0 times negative 5 is 0. All right. We need to plot 0 on the number I'm worried about. Well, 0 is the number I'm worried about. And let's see, we have a less than or equal to, so it's going to be filled in. And I want numbers smaller. Numbers smaller than 0 or equal to 0 are the non-positive numbers. Okay, it can be 0 and anything less than that. Excuse me. So let's go ahead and try, no, I don't know, let's go negative 10. Okay, I picked negative 10 because it divides into negative 5. So we go negative 10 divided by negative 5 minus 6. Is that greater than or equal to? Negative 6. We're going to see. So negative 10 divided by negative 5 is a positive 2 minus 6. Greater than or equal to negative 6. That's going to be a negative 4. And negative 4 is greater than negative 6. So that works out. We're happy. Alright, this next one looks a little tricky. We're going to get it done anyways. Okay, let's go ahead and look here. Actually, you know what I want you to do? I want you to pause this and try this one. Alright, hopefully you had a chance to get that done. Let's go and look at what you did. Hopefully you multiplied by 5 first, because remember there's a hidden parentheses up there that we need to do that division first. So we're going to multiply to get rid of that division. Oh, not less than or equal to, just less than. And 3 times 5 is 15. Subtract 10. X less than 5. Okay, so we throw 0 down there, put 5 over there. It can't be 5, but it can be anything smaller than 5. And let's check that out. There, I was looking a little rough, but it's there. Okay, to check it, I'm going to use 0 because it's an option. 10 plus 0 divided by 5. Is that less than 3? Let's check it out. 10 plus 0 is 10 divided by 5 is 2. And 2 is less than 3, so we're good to go. Okay, that checks out. That one checked out too. And yeah, that one did too. Alright. Now let's go ahead and move on. We have a little bit trickier problems. And the trickier problems being that we have parentheses involved. Alright, so I'm going to do 2 of these. You're going to do 1 of them. Get rid of parentheses first. And we have 4m. So we distribute here, minus 28. Alright. So negative 8 greater than or equal to, I'm going to go ahead and, I don't know why I did that. Skip that step. That was doing nothing. We need to add 28 to both sides. Okay. Negative 8 plus 28 is 20. Greater than or equal to 4m. Divide by 4. Divide by 4. Okay, this is all solving equations review. The only difference is it's not an equal sign. So we get 5 greater than or equal to m. If you want to rewrite that, you can, where m is less than or equal to 5. Okay, it's the same thing, just written the other way. And we put a number line down here. And on my number line, I'm going to have 0 here, 5 here. I want all numbers smaller than 5, but it can also be 5. And so we shade to the left. I'm going to give you a break and say that we don't have to check these. There's really no reason to check it if nothing weird happens, like dividing or multiplying by a negative. So we won't worry about that. Alright, move on. Let's distribute first. Negative 125 less than 8n plus. Here we have 7n. And there we have minus 35. First thing I'm going to do is combine my like terms here. And so I have 125 is less than 15n minus 35. So I'll add 35 to both sides. Okay, those go away. And when I have negative 125 plus 35, that's going to be a negative 90. Negative 90 less than 15n. And when I divide by 15, I'm going to get Negative 90 divided by 15. Grab a calculator if you have to. Negative 6 is less than n. Okay? And really what that's saying is I want all numbers that are bigger than negative 6. So 0, negative 6. It can't be negative 6, but it can be anything else. If you wanted to check it, 0 would be a good number to use. All right. Go ahead and pause the video and try that last one. Okay, hopefully you got a chance to do that. Let's go ahead and distribute first. Hopefully that's what you did. Negative 24x, and there we have a negative 40 plus 5 greater than negative 91. Hopefully you combine like terms first to give you negative 35 greater than negative 91. Add 35. Whoa, hold on. I messed up. 8 times 6 is not 40, it's negative 48. See, even I make mistakes. And so that's not a negative 35, that's a negative 43. Alright, so I should be adding 43 to both sides. You gotta keep an eye on me, I'll tell you what. Alright, so I'm adding 43 to both sides, and I get negative 24x is greater than, let's see, what's that going to give me? 45. And negative 45. It's not a big deal if you make mistakes, as long as you check it first, and it's not 45. I'm struggling today. That's a 48. That's right. Now it works out good. When we divide by negative 24, key thing here, I'm dividing by a negative, and we get x is less than 2. Alright, after all that mess up, I'm looking for numbers that are smaller than 2, and it cannot be 2. So we're looking over there. Alright, very good. Let's go ahead and move on. Okay, we got to get this stuff done. Alright, I'm getting a little bit long here, but that's okay. Now, we have some special things going on. Let's go ahead and distribute first. I have the same problem. The only thing that's different here is the sign, the inequalities are flipped. So I have 6x minus 12 is less than 6x plus 4. When I subtract 6x from both sides, those go away on each side. So I have negative 12 is less than 4. All right, is that true? That's what you have to ask yourself in this case. It is true, right? All right, so what we do, since it's true, we have, infinitely many solutions. We're just going to say that all real numbers would work. All right, if you're shading it, you'd shade the entire line. Okay, and it would go on in each direction forever. Okay, any number that you plug in is going to work in this case. Let's look at the other situation. We'll distribute again. We have 6x minus 12 is greater than 6x plus 4. When I subtract 6x from both sides again, they both cancel out. And I have negative 12 is greater than 4. So these are the two different things that can happen on these problems. Is either it's true, or since this one's a negative, that makes this one false. So the opposite is true. Notice that here we had all real numbers work. Here we're going to have no solution. All right. So even though these are the only two special cases, I want you to try these last three, and it doesn't mean that they're all going to be these special cases. You may have one or you may not. Go ahead and pause the video and try them. All right, here we go. Last 3 problems of the day, even though it's getting a little bit long, we're going to power through these. First thing you should have done was to combine like terms. I have a negative x and a positive 2x. That's going to give me a 1x plus 2 greater than 6x plus 12. I'm guessing a lot of people subtracted the x. You could have subtracted the 6x, but I am always going to move the smallest one. Notice I said that when we had a variable on both sides when solving equations. I'm saying the same thing again because now it's really important. What do I get here is I get a positive 5x. Okay, that positive 5x means I'm not going to be dividing by a negative. That's really good. I don't like dividing by negatives because then I have to remember to flip the inequality. I'm going to subtract 12 from both sides. And we get negative 10 is greater than 5x. Divide by 5. And we should have x. I'm going to rewrite it the other way here. Should be x less than negative 2. Let's throw 0, negative 2. It can't be negative 2, but it can be anything smaller. So we shade this way. Okay, next one. A lot of stuff going on here, a lot of distributing that we have to do, and combining like terms. So we're going to start off with the distributing. That'll be 12x plus 6 plus 7x. And I'm just rewriting the rest. That's a positive 15x minus 6. Okay, yeah, 15x. All right, combine like terms. I have one here and one here. That'll be a 19x plus 6 is greater than or equal to 15x minus 6. Remember, move the smaller one. 15 is smaller, so I'm going to subtract that one. Again, if I would have subtracted 19, I would have had a negative number, and I don't like negatives. So that'll be 4x plus 6 is greater than or equal to negative 6. I'll subtract 6 from both sides. And 4x greater than or equal to negative 12. I'm going to continue it up here a little bit. I'm going to divide by 4, and I'll have x is greater than or equal to negative 3. So we have 0 here, negative 3 there. Whoa, why would I have negative 3 on that side? Negative 3 is over there. And I want numbers bigger than negative 3, and it can also be negative 3. So we shade that way. All right, last problem of the day. Trying to get you guys out of here. Distribute first. Okay. Now I want to combine like terms. I have a positive x and a negative positive 4x, negative 3x. It's going to give me a 1x plus 12 is less than or equal to negative 16. Sorry, x minus 16. Ignore that. That's a mess up. All right. I'm subtracting x from both sides. Ho-ho, what's going on here? X's go away. 12 less than negative 16. Is that true? That is false. And so we have no solution. No solve. All right. Hopefully that made sense to you. If you have any other questions, feel free to ask me. Sorry that the video drug on a little bit. We've got a lot of stuff done today, and that's going to make the rest of the section or the rest of the chapter really easy. Thanks for playing along, and I wish you guys luck. All right, we're still counting down our top 4 bad lip reading clips from, well, these ones are all from YouTube. So number 4 was NFL. Number 3, The Walking Dead. I hope you enjoy.
You think you're black? I'm black, yeah. Brother, you got skin like an English kid. Well, I don't like coffee, but you eat a bagel.
Hey, you know what animals I like? Sharks and skunks.
That's great.
Listen, pretty redneck. I'm taking your banjo.
Come on, don't. That's not cool. He needs his banjo for the talent show.
Man, that's no fair. All I have is a guitar. You get a banjo?
I don't want to mess up your dumb potato basket.
A woman thug stole my banjo. You have a new one?
Got cheetah candy, but it's pretty gross. Now I gotta poo again.
No, you just went.
Oh, yeah. Oh, Kitty. Oh, you're bleeding on me. Oh, yeah. Oh, yeah.
A friend of mine got a foot, and it's juicy.
What the hell are you talking about?
You know, fish can hear you thinking just before you sneeze.
Choppy chop chop. What's choppy chop chop?
Huh? God. Hey! It's hurting my neck. See, I coughed.
Christine!
Hey, I just heard that.
Oh, excuse me. I broke wind.
Did you have bologna and the fish sticks? That's just great. Knock, knock.
Who's there?
Why don't you zip it?
Cheesy bird mess. What'd you just say? I have a cheesy bird mess? Dreet.
Uh-oh. What happened?
He said dreet, and I'm about to freak out. I just can't whoop him. Yeah. I farted on you when you put banana peppers in the Wheaties. Now, Jim? Or are you Mark?
Hey, do you remember that costume party? You went as a penguin and I went as a pink shark. Did you notice the teeth? 'Cause everybody else told me I was neat. The tiny clown, he got wet. I was talking to a psychic. And I can't sleep in the ozone. There's too many different peanuts looking sad.
I would like to go now.
Candy canes will wreck y'all's bowels. You got a problem.
I want a brown girl.
Hey,
she's
I'm
so
standing
white
right
and
here.
not exotic.
Kevin, go
I want
away.
another one.
Jeez, he's a spaz.
I just peed.
You gross. Guess what? I just ate a hot dog.
Yeah. Yeah. Yeah.
Let's get to it. We're on Broadway. I once knew a kid, his tongue fell off in his sleep. La bibbidi bibbidum, what? La bibbidi bibbidoo. This is a violet. No, it isn't. Well, it could be a flower. The other night, there's this movie that's all about gardens called Bloody Shrimp. You got a problem? Yeah. I just found out that we missed Halloween. Yeah. I always wanted a Wookiee, then I found out they weren't real. Thanks for nothing, George Lucas. La bibbidi bibbidum, la bibbidi bibbidoo. La bibbidi bibbidum, getting old. La bibbidi bibbidoo, no more. La bibbidi bibbidum, come on, stop it. La bibbidi bibbidoo, you're like a dope fiend. Cluck went the chicken, and that's how they do it on Broadway. Hey,